All right, so we are doing Unit 10. Unit 10 is about stoichiometry. So essentially stoichiometry, we're going to do everything that we did in Unit 9. So we're going to be converting between moles, number of atoms or molecules, and grams. But now instead of just doing that for one substance, we're going to do that for multiple substances or two substances. So how do we go from one thing to the other? We're going to use stoichiometry. So what stoichiometry is, the technical definition of stoichiometry is the quantitative study of amounts of reactants used and products formed in a chemical reaction. So basically, chemists, what they're most concerned about is, given a certain amount of our reactants, remember everything on the left-hand side of the arrow, those are our reactants. So if we have a certain number of reactants, how much of our product can we make? But you can use stoichiometry not just between products and reactants. You can use them between both of your reactants or both of your products. Okay, but most of the time we're going to go from reactants to products. So if you were there with us on Tuesday when we did our s'mores lab, we used the example of making s'mores. So we had our marshmallows, we had our chocolate, and we had our graham crackers. Those are all of our reactants. Those reactants are going to come together in a certain ratio or a certain amount, and they're going to come together to make our product, which was our s'more. Another example of stoichiometry is a peanut butter sandwich. So let's say you wanted to make a peanut butter sandwich, and for some reason you needed to find a recipe. And you went online and you found this recipe that said that you needed 2 pieces of bread and 1 jar of peanut butter for your 1 peanut butter sandwich. So with those 2 things, with those 2 reactants, you could make 1 peanut butter sandwich. So then your balanced chemical equation would be as followed. 2 bread plus 1 jar of peanut butter yields 1 peanut butter sandwich. So that is your balanced chemical equation. For this unit, you will always need a balanced chemical equation before you start anything. So before you can even read the question and look at the answer choices, you need to make sure that you have a balanced chemical equation. Either I will give it to you, or you need to remember and know how to take a bunch of words and turn them into formulas and then balance it and make it into a balanced chemical equation. Okay? So, stoichiometry is based on the law of conservation of matter or mass. So remember, we cannot make something from nothing. Whatever our reactants were, they just rearranged themselves and made them into our products. So we have to have the same amount of our reactants as we do our product. It has to be balanced on both sides. So we have to have a balanced chemical equation in order to figure out how to convert from one substance to the other. We have to have a balanced chemical equation. Have to. Okay. Because your balanced chemical equation acts as a cookbook or a recipe for a cook. So your balanced chemical equation is going to act as your recipe. It's going to tell you how much of your reactants you need in order to make how much of your product. That number that's going to tell us how much of our reactants and how much our product we have, that number is called your coefficients. So I think we've already done balancing equations. Yes, we did that, right? Yeah. We already learned about coefficients. So this word should look very similar, or very, not similar, very, yes, thank you, familiar. So this word, coefficients, those are your big numbers in front of your compounds in your balanced chemical equation. Remember, when you balance chemical equations, you cannot just throw in subscripts wherever you think it needs to be. You can't use the little numbers in your compounds. You can only write the big numbers in front. You can only add coefficients in order to balance your chemical reaction. Once you have those coefficients, and once they are correct, according to your balanced chemical equation, once you have those coefficients, then those coefficients will tell you how much of that compound you have, or how much you're using, or how much you're going to produce inside your reaction, or during your reaction. So your balanced chemical equation, you cannot do any of this without it. So you have to have a balanced chemical equation. Again, either I will give it to you or I will give you a bunch of words and you have to magically make it into a balanced chemical equation. So for example, if I have this number in this substance, if I have this somewhere in my chemical reaction, this number tells me, this is my coefficient, the big number in front tells me that I have 4 of those things. Those things either being molecules or number of formula units, or most importantly, the number of moles. So the thing that we're going to use 9 times out of 10 in this unit is this, number of moles. So your coefficient, the big number in front, is going to tell you how many moles of that substance you have. 4, yes. So the big number in front is 4, so that tells us that we have 4 moles of magnesium oxide. So if I have this balanced chemical equation, so the equation between hydrogen gas and oxygen gas producing water, if I have this balanced chemical equation, you tell me, what is my first reactant?
Hydrogen.
How many moles of hydrogen gas do I have? 2. How many moles of oxygen gas do I have?
1.
How many moles of oxygen gas? What's my coefficient? Your coefficient is a big number in front.
1.
I have 1 mole of oxygen gas. How many moles of water do I have? 2. So the coefficient that is in front of your substance in your balanced chemical equation, that tells you how many moles of that thing you have. It tells you how many molecules, yes, but we will use the number of moles. Okay? Because we're going from one substance to the other. So the thing that you have to remember is that you cannot go straight from grams of one substance to grams of another substance. The only time that you can convert between 2 different substances is using moles. So that is why this number is so important, is because the only time that you can do stoichiometry is if you have the number of moles of each of your substances. Those come from your coefficients, which come from your balanced chemical equation. So you have to have a balanced chemical equation, you have to have your coefficients in order to go from moles of one thing to moles of the other thing. All right, so for your first example, I have this bunch of words. I need to first turn this into a balanced chemical equation. So, iron metal. What is the abbreviation for iron?
Fe.
Fe. So that is my first one. Plus, what is my second reactant?
O2.
O2. Notice that I'm going to leave a space in between my plus sign and my O2 because I have to write coefficients. So leave a space when you're writing your balanced chemical equation.
Even if it's 1?
You don't know if it's 1.
Well, yeah, but even if it is 1.
Well, if you balance it and it is 1, then you just wouldn't write a number. But you don't know that until you go to balance it. So then, iron metal reacts with oxygen gas to produce. That's going to tell you where your arrow goes. So now my arrow goes next. And then what am I producing? What is my product? Iron 3 oxide. How do we write iron 3 oxide?
Iron.
So Fe. And then what's oxygen?
O.
O. What is this telling me?
There's 3 of them.
That is my oxidation number of iron. Remember, your oxidation numbers go up top. So this is plus 3. What is your oxidation number of oxygen? Minus 2. Is this ionic or covalent? So what do you do with those 2 numbers? Crisscross and bring them down. So then your product would be Fe what? 2O3. So that is what you're going to have to remember how to do during this unit. Okay? So now we have our chemical reaction, but now we need to balance it. So how would I balance it?
Put the 2 on Fe2O3. No, not there. Put the 2 on
Wait,
what you produce.
he's blank.
And now put the 3 on O2. And then put 4 on it.
So that is your balanced chemical equation. So you have
Oh.
3 times 2, 6 oxygens. 3 times 2, 6 oxygens. 2 times 2 is 4 irons, so you need a 4 here. So this is your balanced chemical equation.
Alright. No, that's nothing.
All right. So now, what are my number of moles of each of my substances? So how many moles of iron do I have?
4,
How many moles of oxygen do I have?
3,
And how many moles of iron oxide do I have?
2.
So, you need a balanced chemical equation because you need to get your coefficients. Your coefficients come from your balanced chemical equation. Your coefficients tell you how many moles of each of your substances you have. This is what we're going to be using in order to go from moles of one thing to moles of another thing. So that's why you have to have a balanced chemical equation. You have to figure out what your coefficients are. If you do not do those two things, then you cannot do any of this unit. Okay? All right. Any questions so far? Yes. Any other questions? All right. So, how are we going to use these things in order to go from one to the other? We are going to use what's called a mole ratio. So a mole ratio, what a mole ratio is it basically a fraction of two numbers. And those two numbers are the number of moles of two different substances. Those two different substances can be 2 reactants, 2 products, or 1 reactant and 1 product. Now, you can write the ratio between multiple substances, but a mole ratio that you use in your calculations are between 2 things. But if I'm just asking you for the ratio of your, let's say you had 3 reactants, and I want to know the mole ratio of those 3 reactants, then yes, you could have a ratio between 3 different substances. But for your calculations, for the math, you're only going to be comparing 2 substances. So you're going to be either going from 1 reactant to another, or 1 product to another, or more times than not, 1 reactant to 1 product. Because remember, essentially, chemists want to know, okay, if I have these reactants, what kind of products and how much of those can I make? So that is what we're going to use. We're going to use a mole ratio to go from one substance to another. We're going to go from moles of one thing to moles of another thing, because we cannot directly go from grams of a substance to grams of another substance, or number of molecules of one substance to number of molecules of another substance. We have to go from moles of one thing to moles of the other thing. That's the only way. Okay? So then, how would you write your mole ratios for the following questions? So again, given this balanced chemical equation, now we need to write our mole ratio. So our mole ratio is a fraction. We're going to have something over something. Our mole ratio is between the moles of our substances. So if we want the mole ratio of iron and iron oxide, we would have moles of iron on top and moles of iron oxide on the bottom. Where do our numbers for our mole ratio come from?
Coefficient.
Our coefficients. So what number am I going to write here? And what number am I going to write here? 2.
Yo.
So, depending on what so if I ask you a question on your test of what is the mole ratio between this and this, or this and this, you would not simplify this because you are showing what the numbers are in the balanced chemical equation. So you can't reduce this. You have to keep it whatever numbers are in the balanced chemical equation. Because then if you reduce this, then your numbers are different, but those are not the numbers from the balanced chemical equation. So if I'm asking you for the mole ratio, keep it however the numbers are in the balanced chemical equation. If you are using this in your calculations, I don't care if you reduce this or not. So you're going to have this as like your picket fence. If you want to do whatever this is, times 4 divided by 2, that's fine. If you want to see that this would be reduced to 2, and then do 2 times whatever this number is, that's fine too. That doesn't matter. But if I'm asking you what is the mole ratio, just keep it like that. Okay? So then what would the mole ratio be between iron 3 oxide and oxygen gas? Yes, Will?
It would be 2 moles of iron oxide over 3 moles of oxygen.
Over, what'd you say?
3 moles of oxygen. Or
Perfect.
moles of iron.
Perfect. So that is your mole ratio between iron 3 oxide. So moles of iron 3 oxide would go on top because a mole ratio is moles of one thing over moles of another thing. So your moles of iron oxide over your moles of oxygen gas. Your numbers for your ratio come from your coefficients. Your coefficients come from your balanced chemical equation. So whatever coefficient is in front of your substance, that's what you would write here. So we have 2 in front of iron oxide, and we have 3 in front of oxygen. So it would be 2 moles of Fe2O3 over 3 moles of oxygen gas. So those are your mole ratios. That is how you go from moles of one thing to moles of the other thing. This is what you're going to use in your picket fence method for this unit in order to go from, let's for example say moles of oxygen gas to moles of iron oxide. Okay? Alright, one more thing about mole ratios before we do some examples. So what you can do is you can think of a mole ratio being acting as a bridge. So the mole ratio is going to act as a bridge in between your 2 different substances. So anytime that you have to go between different substances, you need to use a mole ratio as a bridge to go from one substance to the other. You cannot go from one substance to another unless you are using the moles of those 2 things. You can't go from grams to grams. You can't go from number of particles to number of particles. You have to go from moles of one thing to moles of another thing. So at that point, you are going to use a mole ratio. Okay. So you have to have your balanced chemical equation, you have to have your coefficients, and you have to have your mole ratio. Those 3 things you have to do any of these problems. Okay. So, for the first example, I have hydrogen gas reacting with oxygen gas to produce water. how many moles of water will be made from the reaction of 5 moles of hydrogen gas with oxygen gas? So this is a good example of one of the easier questions that you could get for this unit. So the first thing that you're going to do is you're going to turn this first sentence into a balanced chemical equation. So if I have hydrogen gas reacting with oxygen gas to produce water, what would my equation look like? How would I write that? Do I do equals?
Arrow 2.
What? So that is my equation. Now I need to balance it. So how would I balance that?
You start by putting it on the other side of the H2.
Okay.
Yeah. And you put 2 on the H2.
So then 2 times 2 is 4 hydrogen, 2 oxygen, 2 oxygen. Very good. All right. The second thing that you need to do, or at least what I recommend doing, so again, you do not have to do this, especially if you are a person that can do all of this in your brain. You do not have to do this, but I highly recommend that you do, at least starting out, so that you can keep track of where are you starting and where do you need to go. So what is your point A, what are you given, and where are you wanting to end with? So I need, what is it asking you to solve for? You need what? What is it asking you to solve for? Moles of water. So that's where you need to stop at. That's what you want to get to. This is your point B. What are you given? What is your point A? You are given 5 moles of hydrogen gas. So that is the first thing that you need to do. Before you even start doing calculations, you need to make sure you have a balanced chemical equation, and then you need to realize where are you starting and how are you going to get to your end point. Okay? So then, remember how we do our problems is that we use the picket fence method. So we always start with what we're given. So we were given our 5 moles of hydrogen gas. We draw our giant plus sign. We want to get rid of this. How would we get rid of moles of H2? Where would they go in the next step? Diagonal on the bottom right. So this is what I want to get rid of. It has to go diagonal. So I'm going to write moles of H2 on the bottom. So then what do I want to end with? What do I want to be left with? So moles of H2O are what's going to go on top. This is called your mole ratio. You're going from moles of one thing to moles of another thing. Where do your numbers for your mole ratio come from? Coefficients. So what number am I going to write here? I'm going to write a 2 here because my 2 is in front of my H2O. And what am I going to write here?
2.
Also a 2 because there's also a 2 in front of my H2. So then, once you have your picket fence method set up and everything on top gets multiplied, everything on the bottom gets divided.
5.
So you can do 5 times 2 divided by 2, or you can realize that this can be reduced to 1. So 5 times 1 is 5. And then you need to write your number, your unit, and your substance. Because are you talking about water or are you talking about hydrogen gas?
Moles of H2O.
5 moles of H2O. That would be your answer. Okay? So, to go from one substance to the other, so to go from hydrogen gas to water, I have to use what's called a mole ratio. The mole ratio is moles of one thing to moles of another thing. The number comes from my coefficients of my balanced chemical equation. Are there any questions about mole ratios? Any questions? All right, so then this one. So I give you the balanced chemical equation. So you tell me how many moles of silver would be produced by reacting 2 moles of copper.
Okay, respectfully, this is nothing like the last problem.
How is it not?
Because there's parentheses and there's a
But
thing.
it's
Just
balanced.
because your equation is not the exact same does not mean this is not the exact same problem. I have given you your balanced chemical equation. What are you starting with? What are they asking you to solve for? And how are you going to get from point A to point B? Well, this is moles of copper, and this is moles of silver. So how do you go from moles of one thing to moles of another thing? What are you going to use? What is it called?
Mole ratio.
A mole ratio inside your picket fence, yes. Where do your numbers for your mole ratio come from?
The coefficients.
Of your,
I don't know, elements, whatever those things are. Yeah, those.
what's the whole thing? What is it called?
What?
Balance,
Chemical equation.
chemical equation.
Yeah, the best part is literally it's already balanced. So like,
Right?
my word.
So then it would, or should,
Before.
look like this.
I did that in my head.
Right? So you start with your 2 moles of copper. You do your picket fence. I know it looks a little bit different, but it's still your picket fence. Your moles of copper, that's what you want to get rid of. So your moles of copper need to be diagonal. So your moles of copper go down here. Whatever you want to be left with, our moles of silver need to go up here. We need to look back at our balanced chemical equation, and we need to see that there is a 2 in front of the silver, and there is a 1 in front of the copper. If you do not see a number, that means there is a 1. It would not be 0, it would be 1. Okay? If it was a 0, then we wouldn't even write it in the first place. So then you would do 2 times 2 divided by 1, which is 4. So you have 4 moles of silver. Do that one.
Oh my gosh.
Oh no.
Is it balanced?
Oh, real quick. What type of reaction is this? Who remembers?
Ironic?
What type of reaction?
Covalent.
It's because you got double.
Oh.
Not double, single. Single replacement because you have a single
You're
element.
gonna have to know that for the test.
No, I was just seeing who remember.
Bonus question.
What type is that?
Already balanced. Yeah.
What type of reaction is it?
No, no.
No, it's a single replacement, dude.
No, it's combustion.
I said it
Combustion.
first. I said it first.
Very good. Very good.
This when is it balanced already?
It is balanced already. So, before you leave, solve this problem. Tell me how many moles of oxygen are needed to react with 7.5 moles of C8H18.
So why? How many was it? 25, 6.
Can you stop talking, Will?
Oh my God, see, no, no.
25 times 7.5 divided over 18.
So how do you solve?
Really? 25.
So start with what you're given. Do your picket fence. Use your mole ratio. Your numbers from your mole ratio come from where? Coefficients in your balanced chemical equation, which is provided. Set up your picket fence. Do the math. You may need a calculator. You can use your phone for this one.
Hold on, don't
This
say
one,
it.
can you flash the answer? Stop saying that.
You'll find out soon enough.
That's what come out.
You can wait. You still have
Still have 5
a
minutes.
few minutes. Really?
That was him. I promise, that was, I mean, I was laughing, but that was him who made the noise.
What? Oh, the noise you
Oh, I don't know.
Hey, this way. Will got it wrong and I got it right.
It's like I did not get this wrong, okay? I'm just
All right. What did you get for an answer?
Four, yeah.
93.75 moles of O2. Very good. We will do more practice tomorrow.